app, so that when I go to upload your video, it's 3 hours long, and it won't upload at that time. So if you ever see me record, if you could remind me to stop recording, that would be a helpful piece. Okay. All right.
Got it.
We all good? Okay. Hey, because we said something intelligent about limits, we can now talk about continuity. And continuity is very, 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 very simple. And when I say simple, I mean simple to simple. Okay? Watch this. One of these functions is continuous. One of them is discontinuous. Which do you think is discontinuous? The one on the right or the one on the left? One on the right's discontinuous. Very good. Nice job. Yeah, continuous in the stupid sense is simply if you could draw it without picking up your pencil, then it's continuous. So I'm drawing a continuous function right now. It's not very pretty, but it's continuous. Okay? And continuous functions are nice because anywhere you point, there's a limit that exists. Whereas in this situation, does the limit exist here? No. So once we formalize limits, then we can talk about continuity. And it's important to talk about continuity because this is like the last thing we have to do is talk about continuity, and then we can start doing what we call derivatives in calculus. You can't do derivatives if you have discontinuities. No bueno. So let's start it. Continuity. A function f is said to be continuous at a number a, so at a number a, this number a, if, number one, f of a exists. So if you plug in a and you get an output, that's one requirement. If there's no output, then it's discontinuous. Second is the limit as x approaches a of f of x must exist. And the third requirement for continuity is that the limit as x approaches a of the function must also be equal to the function value. And so the true definition for continuity is the limit as x goes to a of f of x is in fact f of a. You're going to memorize these three for the test. It's not going to be a big deal. You need to memorize them in that order. You guys are going to do fine with it. We'll practice it. Trust me, it'll be good points for you. I have right here a function that's shown in front of you. There are x values at which this is discontinuous. What I would like you to do is talk to the person next to you and list any x values where this is discontinuous. Ready, set, go. Five, four, three, two, one. Somebody want to give me one x value where this is discontinuous? 1. Very good. It is discontinuous at x is equal to 1. Where else is it discontinuous? It's discontinuous at -5. Where else is it discontinuous?
4.
At 4. Those are the 3 spots of discontinuity. That's what you're going to have to identify in your assignment today as well as on the test. Are there any questions about those discontinuities? The second thing you're going to have to do, which is just a little bit more critical, is you have to identify why it is discontinuous. And you go through the process of the test that we have up above. Please start with number 4 for me, okay? We start at the very beginning, okay, which is this. It says, does f of a exist? If I plug in 4, is there an output? No. So this one fails. So 4 fails. Number 1, because f of a does not exist. Ooh, I'm using bad language here. I wrote does not exist. We should really say undefined. We won't confuse that. Just write does not exist. It's fine. And on the test, to be clear, you could just write fails number 1. You don't need to write anything after that. As long as you've listed those there, then I could go right off that. You got that? Let's look at number 1 right here, okay? Does f of 1 exist?
Yes.
Yes, what is f of 1?
6.
It's 6. So it passes the first test. So then we move on to the second test. Does the limit exist at 1?
No.
No, because the limit from the left is different than the limit from the right. So this fails number 2. The limit as x approaches a does not exist. Okay? And then we get to our third example. Number at -5. Does f of -5 exist? Yes, what is it?
3.
It's 3. So we check the box for the first one. Then we try the second one. Does the limit exist?
Yes.
What is it? It's 7. Then we go to the third one. Is 3 the same as 7? No. So this fails number 3. Now, every once in a while I have a student who tries to get kind of cute with me, and for every single answer they write number 3. Technically, if it's discontinuous, they all fail number 3. I want to know in which order it fails first. Do you see what I'm saying? So you must list the 3 criteria. Why do I do that? Because that's exactly what was expected of me in college. I see them laying it out just like that. So I want the same for you guys. Flip it on over. Hey, I heard somebody say the other day that they needed more practice with piecewise functions. So I thought, let's just bring it back. Okay? What we want to do is explain why this function is discontinuous and then sketch a graph of the function. So we have f of x equals x squared minus 4 over x minus 2. Does everybody agree that this is going to be discontinuous at 2?
Yeah.
Why? Because it produces 0 in the denominator. Everybody good there? Okay, so let's just sketch the graph. We're going to do x minus 2 times x plus 2 over x minus 2. The x minus 2's will reduce. That means that this function wants to look like x plus 2, except it's discontinuous at 2. So what that means is I draw my function. And when I get to the number 2, I leave an open circle. Okay, if it divides off evenly, that means we have an open circle. So on the test on your assignment, I'm going to need you to sketch the graph, and I'm going to need you to determine which of the 3 rules it fails. First of all, does f of 2 exist? No, it doesn't. Does the limit exist?
Yeah.
Yes. So this fails number 1. I want you to see if you can draw the sketch of the graph for letter B on your own. Go ahead and see if you can sketch letter B on your own, and then identify the continuity issue. Very good with the graph? Does it pass number 1? Yes. Does it pass number 2? No. Fails number 2. The limit does not exist.
Do you want us to always write an explanation or just write fails?
You could just write fails number 1 or number 2. In accordance with, I just want to be clear that that is predicated upon the point that I will ask this question on the test. So that way I'm referencing number 1 and number 2.
Got it.
Good? Okay. So our last 2 examples, okay? And as you look at this one real quick, I want to use this as a teaching point here. We have a function. I'm going to write a new function, g of x is equal to, and I'm going to write a piecewise function here that fills the discontinuity. And I'm doing this because I've never done this before, but I think this is going to help you for the next part. So I'm kind of going off cue here from what I've previously done. Our new function is going to be the same as f of x, which is x squared minus 4 over x minus 2. And that's for when a does not equal to 2. Everybody agree that this is the graph when we do not have a value at 2? So now what I want to do is I want to fill that discontinuity. So when a is equal to 2 or x is equal to 2, okay, what y value would I have to have in order to fill that discontinuity? 4. You filled the discontinuity. So the red graph with the blue is this one. It actually fills that discontinuity. And as we move further along, that's what we're going to be doing when we find derivatives, is we're going to be filling discontinuities all the time. So we'll do these two. Now that you've seen that, this should work fine. Does everybody agree that this is not continuous at -3? Because it produces 0 in the denominator. So therefore, we're going to write a new function, g of x is equal to x squared minus 9 over x plus 3 when x is not equal to -3. Because we notice as we plug in -3, we get 0 in the denominator. But notice we also get 0 in the numerator, don't we? And anytime you have 0 divided by 0, we notice that it will divide out. X plus 3, x minus 3 over x plus 3. Anybody want to guess what y value I should have in order to make this continuous? How'd you get that, Danny? Plug in that -3 value to the remaining term. -3 minus 3 is -6. That's all there is to it. Yeah, thank you, Arky. Our last example, g of x is equal to x cubed minus 1 over x minus 1 when x is not equal to 1. Everybody recognize that if we were to plug in 1, you get, again, 0 divided by 0? Yeah. So we have to figure out what should the x value be here for, given x is 1, what should the y value be? Uh-oh, what if you don't remember how to factor cubes? Yeah, you could do synthetic division. So if you don't remember how to factor cubes, you could just go 1, and then 1, 0, 0, -1. So when in doubt, turn to synthetic division, drop the 1, multiply, add, multiply, add, multiply, add. So you can see that this, if you divide it out, becomes x squared plus x plus 1. So what should my y value be to fill that discontinuity? 3. You have filled the discontinuity. That's it. Continuity. Nice thing. Tomorrow we will do a lesson on intermediate value theorem. But we should be ready to test next week. Okay? You guys did. We will not test Monday.
Maybe Friday.
We'll not test Monday.
So that's intermediate value.
Right now I see us testing on Wednesday next week. Okay? So if you pin me down to it, Wednesday next week.
Wait, yes, which is our homework? I'll make sure you stop your video.
Oh, thank you.
Say goodbye.